Hey everyone, Mr. Newman here, and this is part 2 of the Unit 3 test review. Just like the first part, I would highly recommend that you try each of these problems first, and if you get stuck, then play the video. But also play the video after you finish it to make sure you got the correct answer. So, let's get started. 2 amusement parks open their doors at the same time. Each lets people in at a constant rate until they are full. The people entering each park are represented below. So we have a graph and we have a table. Now I will tell you this will not happen on the test, but there is a typo on the graph, and I'll talk about that in a moment. Do you notice these 2 numbers I circled? 275 and 330? Really those numbers should keep going up, but here they don't, and I'm going to blame Microsoft Word and Google Docs for that one. The picture did not format over correctly. But let's check and answer the first question. It says, are the functions modeled by 2 parks linear? In other words, do they make a straight line? Well, in order to test numbers, we need to see, okay, how much is this increasing by? What's the rate of change? And you notice each of these goes up by 55. So from 275 to 330, are we going up by 55? Yes, we are. And notice that the x, the time in minutes, goes up by 1 each time. You might need to fill in those numbers there because they might not be there, and that is going to be helpful for later parts of this problem. Notice on part B, this is also linear because the rate of change is 40 over 2, and that is true for all of them. So yes, because the rate of change is constant. It also tells us in the problem that it lets people in at a constant rate, so we know that the rate of change is constant there. But using mathematics to justify your answer, you have to write the rate of change, which is actually our answer to the second one. So what is, the rate of change for each of these? That's the slope. So I calculate that there. The answer is for A, the slope is 55. For B, the rate of change or slope is 20. And I just did delta y over delta x for each of those, or rise over run. What does the slope mean, though? Make sure you answer both questions on these multi-part problems, okay? That's the slope means people per minute, or how many people enter the park each minute, or every minute. Now, what are the x and y intercepts of the function? They're both 0, 0. What that means is that there were no people, 0 people, in the park when it opened at x equals 0, or time equals 0. In 3.5 minutes, how many people will be in each park? Well, the minutes, that's x, so x equals 3.5. I'm going to just multiply it by the slope. So for A, it's 55 times 3.5, and that's 192.5 people. I can do that because I know the y-intercept is 0, so I don't add anything after multiplying. Likewise with B, 20 times 3.5 is 70, so we know that there are 70 people after 3.5 minutes. All right. This next one requires a calculator, and I'm not going to show you the steps because you can go back and watch that in the video if you forgot, but I'll remind you of the steps. For the first thing you need to do on your calculator is press Stat, then Edit, and L1 is going to be the X, that's the years since 1900. L2 is going to be the percent of farm workers. And to find the linear regression, in other words, to find the equation for the line of best fit, we're looking for linreg, linear regression. We press Stat, then go right one and go to Calc, and then go down to linreg. I believe it's the 4th option there. Once you type that in, you should get this equation. Notice it said round your answer to the nearest tenth. That means negative 0.7, even though that cuts off a lot of the numbers. The slope is negative 0.7, and that's how much the percent of farm workers has decreased each year. So it's percent of the change in y, L2, over the change in x, L1. In other words, the change in percent of farm workers per year. Now, using the line of best fit from part A, what would the prediction be for the percent of farm workers in the year 2020? Well, since the X values say years since 1900 right there. So, because that's the years since 1900, we know that the year 2020 is 120 years after 1900. So the X value is going to be 120. I found that out from subtracting 220 minus 1900 to see how many years have passed from 1900 to 2020. Is this a reasonable answer? Well, let's plug it in to get our answer first. When you plug that in, you get negative 14.5. Is it possible to have a negative percent of farm workers? No, so it's not reasonable. And what happened was we were just following our linear model along and we got out an unreasonable answer. But if we think about what that means, that's not reasonable because the percent of people cannot be negative. What happened here, we just went too far into the future and the line will of course keep decreasing. It passed 0, so it became negative. So, while though those values work just fine, there's probably a different model that's better. But we can safely say that the answer here is not reasonable. Mr. Kronk knows that he uses 2 bars of soap every month, so he looked and saw that he has 20 bars under the sink. Let y be the bars of soap left and x be the number of months. So we've already got our x and our y. I saw the word every, so that's going to indicate slope. So 2 must be the slope. It also says that he has 20, so that's the starting value. So if I made a table, for example, you start 0, 20. At 1 month, he would have 18. Why did I not go up to 22? Well, he uses the bar of soap, so he's losing them. And what this helps me do is this helps me see that my slope is actually negative. Because he's using the soap, that amount is decreasing by 2 every month, so we're going to have a slope of negative 2. So, with a slope of negative 2, I'm going to put that into my equation. Y equals mx plus b. M is negative 2. B is 20, because that's the y-intercept. So y equals negative 2x plus 20. Let me make my table here. I can skip around, or well, I'm not skipping around. The numbers, every hash mark still goes up by 2, but I don't have to number every hash mark. That is soap bars, because it said let y be the soap bars left. And x, it goes from 0 to 5, and then I skip forward to 10, because every hash mark is 1, and that's going to be the number of months. You could pick a different scale, but I like this scale because it fills the graph, and that's one important thing on these. I have the point 0, 20 already plotted. If I plot the next few points, 1, 18, 2, 16, notice I've got the points all the way down, and I can connect those dots, which makes sense. There are 2 ways to approach the domain and range as long as you explain it. Either is fine. You could say, oh, we can only have 0 months, 1, 2, all the way up to 10. And for range, we have 0, 2, 4, 6 because we lose 2 every month, and that's the number of bars of soap left. But because we connected the line, and more importantly, because you can have half a bar of soap left, or 1/10 of a bar of soap, and the month can be halfway through a month, a better domain and range looks something like this, where we have, oops, I'm going to run out of space here, 0, the domain is 0 is less than or equal to x, which is less than or equal to 10, and the range is 0 is less than or equal to y, which is less than or equal to 20. Because this would be considered a continuous domain. So as long as you justify it, both of those are valid. Now, does Mr. Kronk have enough soap left to make it to the end of the school year at the end of June? Justify your answer. Well, I'm writing here, school started in September, so I'm going to make 0 September. 1 is October, 2 is November. And honestly, you guys, there is more than one right answer. If you justify the way you counted, that's what's important, okay? I don't really care which month you start at as long as it's a reasonable one and one that makes sense. If you say, wait, no. 1 should be September, 2 should be October. Great, fine, say that and justify it. Here I justified it by writing them down. And so I want to say yes because it lasts 10 months, the soap bars do. And June is month 9. You notice here, I miswrote that. June is right there at month 9. So he's going to make it to the end of the year. All right, let's do one more problem here. Your soccer coach wants to take the team out for pizza after the game. He wishes to spend no more than $60. Large pizzas cost $12 and sodas cost $1.25 each. There's an important word here. I said no more than 60. The no more tells me that this is an inequality. Now, you could also know that because I wrote the word inequality there and down there and even down there. But it's always good to look out for. He didn't say exactly 60. If it was exactly, it'd be an equation. But no more means we're having an inequality and we're going to shade one side on our graph by the end. Large pizzas are $12. Sodas are $1.25 each. So X must be the number of pizzas and Y is the number of sodas. You can switch this and you'd be correct, but as long as you're consistent throughout the problem. The inequality is going to look like this. 12 times the number of large pizzas plus 1.25 times the number of sodas. That, it must be no more than, in other words, it needs to be less than or equal to 60. So there's our inequality. Now, I'm going to graph this. I'm going to graph it by graphing the equation, And a lot of you guys are having trouble with graphing the standard form equations because we've done them so many different ways. If you're having trouble, fall back on this. Make an equation, plug in 0, and solve for y. I'm going to do that right here. I get 1.25y equals 60. And y, when you divide by 1.25, y is 48. I plug in 0 for x, and I find y. I'm going to do the same thing here. Next, I'm going to plug in 0 for y, and I'm going to get x. I'm going to do that down here where I have some space. So 0 in for y this time. 12x equals 60. Divide both sides by 12, you get x equals 5. So my other point is 5, 0. Those are the 2 points I need to plot, and that is all to make this line. So let's go and make 0 through 5 pizzas, and I'll put 1 point there. 5, 10, 20, 30, 40, 50. Notice each hash mark is 5, so I skipped 1 to go up to 20. That's sodas, and I put 1 point right there at 0, 48. Now, I didn't ask, I should have, is this a solid or a dashed line? Because it's or equal to, it's going to be solid, so let me draw a solid line between those. And lastly, which side do I shade? Well, I need to try 0, 0 to see which side of this line I shade. When I plug in 0 and 0, I get 0 is less than or equal to 60, which is true. So 0, 0 is a possible solution, and we need to shade that side. Now, when it asks to give a reasonable or possible solution to this problem and explain the context, we could pick anything. We could pick 0, 0. We could pick 2, 5. We could pick 1, 30, as long as it is on the shaded side. So I just picked 1. That's the point 2, 10. That's a possible solution. Explain what it means. It means he could buy 2 pizzas and 10 sodas, because 2 is the number of pizzas, that's our x, and 10 is the number of sodas, that's our y. Thank you for watching.